Hello and welcome back to the lab. Today on the bench we have something on the high power side of the fence. We have a Transistor Devices Dynaload, model number DLP 5150 3000A. This is 50, 150, and 3000 watts of dissipation in this particular load. I'm not sure if this works. It was in storage and must be calibrated prior to use. We're in a little bit of a rough shape. Handles are falling off, things like that. Buttons are crusty, pots are bent. Typical stuff that sees the bench. Not a big deal. I will be ecstatic if we can get this up and running. And I've needed a load for some heavier wattage power supplies than I have. My Keithley does okay, but it does have some wattage limitations. This will blow those wattage limitations out of the water. And so really looking forward to getting this fixed up and on the bench. What do we got? We have a 6, 18, and 60 volt range. But then we have an 18 amp, 60 amp, and 180 amp range. So to get our 3,000 watts, I'll have to do the math out, but we have a 60 volt range and 180 amps, so this might be able to absorb 60 volts and 180 amps. Now, what does that do to the front of this unit? Well, it turns this into a space heater. So everything that this soaks up, it dissipates in heat, as noticed by the massive fan that's on the top of this. And as I open this up, I think the main heart of this thing is going to be heat dissipation and thermal management. So we have a big power switch here that we can turn the unit on and off on. But then this switch, which is 3 breakers ganged together, that's the main. I want to switch the load on and off and pull on something. We got a 5 amp, 30 amp. We have a 0 to 30 amp, 0 to 150 amp, and a 0 to 50 volt mode, as well as pulse and short circuit. Very cool. Ought to be able to do some really neat testing with this once we get it up off the ground. First things first, we're going to clean up the front end, get all these stickers off of here, get some of this permanent marker off. We'll be able to get most of it off, not all of it, but we'll do what we can to clean up the front. We're going to get this handle reattached. At least I have the screws that it's supposed to go in. This one's kind of off. We're going to have to disassemble this side of the case to get to the Phillips that's hiding under here, I think. But we'll see how far we have to take it apart from there. Hopefully not too far. We'll get these stickers off. And get the front end cleaned up. Next, what's after that, we'll be servicing the potentiometers, the switches, get everything lubed and cleaned, and then we'll see if we have any problems. I expect this to be relatively simple inside, so there shouldn't be too much wrong with this thing as long as the load portion is still intact. This is solid state, so I'm going to bet, especially with our 3,000 watt range, that we're going to open this up and we are going to find an absolutely massive quantity of power transistors that are just strapped to some heat sinks with some fans blowing on all the heat sinks. But we'll get to that when we get to it. First up, let's give it a good cleaning. Well, I got it clean, but I cleaned a little too hard and cleaned the volts off, and the range down here started to come off. The range isn't too bad, but the volts was too far gone, so I finished cleaning that off. We're going to make a label to put under there. So I'm going to poke around, see if I can figure out what the font is that was used on the front of this unit. If I can figure it out, I'd love to fix the coarse and fine label, because that was already a little blown out before it came to me. So I'd love to fix that. But I will fix this range, and then we'll put volts back up here where it should be, and we'll go from there. I've got the knobs off and cleaned those. I still need to reattach the handle. That'll be next. But the front cleaned up real nice. My 99% isopropyl alcohol did attack the printing. Tech scopes, which I'm used to cleaning, and I completely slipped my mind and I totally forgot, they're anodized, so they'll hold up to a pretty decent scrubbing with some pretty harsh chemicals. This is alcohol-soluble ink. This will not hold up to intense scrubbing with chemicals. A light buff was not doing anything. I took the alcohol rag and I just buffed it across, and it didn't attack the paint. Prolonged scrubbing to get the sticker off, took the volts off, and started attacking the range lettering. So we will get that fixed and resolved. I'd like to do it without attacking this red, but we'll see what happens. For now, I have to pop these 4 screws out and pull the side off, and then that's going to get me access to fix the handle. All right, let's take a look at the inside of this thing. Look at some of this cable. This is massive. This is our circuit breaker for the main unit. We have, looks like positive over here. And then every resistor you see here, laying on the ground, over here, every single one of those resistors is a balance resistor for a silicon pass element that's on the other side. There are probably about 100 transistors in here. The entire inside of this, you can see the structures down here. Entire inside of this unit is heatsink. This fan pushes air into the case, and then it blows it out the back through the chimney channels on the sides of the unit. This thing is made to dissipate some power. Not surprising at 3,000 watts. One of the other things that's really interesting on this particular unit, you can see these cutouts right here. This is actually balancing of the fan to make the fan quiet down when it's spinning. So lots of attention to detail. Come back here. Lots of attention to detail on this particular unit with balancing out even the fan blades. We are probably going to have to lubricate the bearing in the fan motor. I have a sneaking suspicion the bearings are going to be dry and probably crying for oil. Moving down, this is the contactor for the short circuit mode. So when you hit the short circuit in the front, this clamps closed, and this is a very, very high current relay that's going to shoot. Just going to short the inputs. The inputs are actually on the back of this unit, not the front, and they are some pretty massive binding posts on the front of this thing. So it's going to be interesting how we integrate this with the bench and hook it up. So for right now, while I have the unit off, or the front panel off because I was fixing the handle, I'm going to clean up and lubricate all the switches and potentiometers. These are nice, really nice wire wound pots. They feel really, really good. But we're going to give them a good cleaning, a little bit of lube, and then we're going to see if the unit functions or not. Okay, to service up this fan bearing, a flathead screwdriver in the base will, come on, focus, will unthread the fan from the motor. Now to get at that screw, there's 2 cover pins, there's a cover, and then 2 thrust washers that are holding everything together and tight that need to come out. Hopefully we can get this cover out. And there we go, we have access to the bearing. I'm going to leave that spring washer in there, but I got to get some oil into that bearing because that top bearing does sound awful. So we're going to see what we can do by getting some oil in here. On this top side, gravity is going to help us. Looks like I'm putting a fair amount in there. This bottle has a very fine needle on it to help control the flow, so it's not overdoing it too much. But this bearing is quite dry, so I do want to get a fair amount on it. Pop that top cover back in. Let's get our C-clip back on there. Needle nose pliers are not the correct tool for this, but I do not have the correct tool in the lab. My C-clip tool is up in the garage. No, there it goes. Okay, now it's seated. But we're pushing it out the bottom, so we got to push that back up front. That's up on the C-clip. Now we need to put the fan back on. Where's my flathead? Make sure that's good and tight. Oh, that's feeling better already, and it's spinning a hell of a lot better than... Oh, yeah. It's really spinning better than it was before. So that bearing was quite in the need of some assistance. 2 spring washers go back in. Our bottom plate goes back on. And we'll use the wrong tool again to put the C-clip in. Did we get it? Yeah, it'll go. There we go. Popped in. All right, let's see what the fan sounds like. We'll put some power on it. See if this bearing doesn't sound better. Okay, I expect this fan to be quite high speed. Just wipe the dust off while I got the grill off. We'll put the bird cage back on it if it sounds all right. And we'll hit the AC. Not great, but much, much better than it was before. It was making some horrible noises. Also wasn't spinning down near this long. Wipe out the fan channel. Let's put the finger biting guard back on it, because God knows I will get my fingers caught in this thing. And to be honest, this is a fairly high-speed fan. If we have to, we'll put some stouter oil in the bearings. Hopefully we don't have to. Hopefully it's pretty good to go from here. We're going to let it run for a while. Make sure it doesn't make any more horrific noises. That is moving quite the amount of air out the back. All right, I have the unit set up for some testing. 6-volt range, 18 amps. We're going to go on the 5-amp mode. I'm going to turn the load completely down. And we're going to turn on the Rigol. Now, the Rigol power supply is not even a match for this thing. So this can suck way more power than the Rigol can deliver. Rigol only goes up to 3 amps. But we'll turn the DC on, and we have 5 volts. So that's excellent. Let's see if we can get it to draw some current. We can. So that'd be about 2 amps already. And the Rigol says I'm drawing about 2 amps. Let's go to 3. I can't with the fine control, which is fine. That's about the limit of the Rigol, 3 amps. So this load is actually working, which is fantastic. We can actually see, because of I2R losses in the cables, one is I'm using standard test leads, and the forks were barely big enough to fit on these terminals. So the connection's not great. So we are losing, when I ask it for 3 amps, the Rigol still says it's outputting 5 volts. 4.998, but we are losing a bit of voltage in the meter test leads as I2R losses. Not awful. Let's see if the 18-volt range works. Yeah, it does. We're down to 5 volts. And we'll see if the 60-volt range works. It does. We're down to 60 volts. So my range switching is working. 60 amps. Barely tickling it at 180 amps. So this load looks like it's up and running and functional, which is fantastic. I do have one beefier power supply than this. Technically, I could use the Valhalla, dump 10 amps, but that's probably the largest supply. I think that's the largest supply that I have in the lab. I do have a linear 30-volt 5-amp supply, but it's what I use to charge batteries. Beast of a supply. Doesn't have a lot of the input shorting out problems. Like if you leave a battery plugged into a Rigel, it'll blow the input. Don't ask me how I know. But this Dynaload looks like it's kicking, which is fantastic. I do want to replace those 2 capacitors on that interim board that's in there. And we'll do that now that we know everything is good to go and my pass elements are okay. It's not even warm, dissipating 3 amps. I mean, it's got a 180 amp range. So I do want to see if I can find the service manual. I'd like to understand a little bit more about what these buttons do. But all in all, I can't complain. I am ecstatic that this thing is up and kicking. Okay, got some labels back. Turns out I had some black on clear labels, so we were able to get the font set up. We'll see how this works. If it annoys me, I'll fix these 2 to match, and we'll go forward from there. I did replace 2 capacitors on this particular unit. They were the power filter caps for the readout board. And I did find out the PCBs that are in here are incredibly fragile. There was some trace damage that I had to repair when I undid. Actually, I think you can see the capacitor where some of the trace came up with the actual cap. So had to fix some of that, get that going. But believe the unit's in good shape. Let's see what we get. Yeah, we're good there. Fan sounds a lot better after I lubricated it and then let it run for a little while. The bearings got a lot happier. They still make a little noise, but that's because they're actual bearings. They're not like maglev or fluid bearings like we have today. So little noise is normal. Crunchy is not. Also, initially when I spoke, I said that this unit could take 3,000 amps. That is not the case. This is a 50-volt, 150 amp, 3,000 watt unit. So this is a little misleading, especially with the A on the end. So it's volts, current, wattage, because obviously 50 volts and 150 amps is more than 3,000 watts. So this unit can load down any power supply that has these, not to be exceeded, and will work very well for some testing that I need to do here in the future. Now I have a conundrum, really, is I have a pretty stout DC load. We know it's off a little bit because it disagrees with my Rigel supply. How do we calibrate 150 amps? So I'm going to have to dig around and see some sources before we do an alignment on this thing. I can use it as is for now because I need to load down some power supplies to do some basic stuff. I don't need to take super precise load measurements. And I can, if I need to take super precise measurements, I can use this in conjunction with a DMM and get the measurements I need. But my next challenge, and if anybody has any suggestions, hit me up in the comments below. How do we get 150 amps DC, controlled DC, into this unit so we can calibrate its highest range? My Valhalla Scientific will only do 10 amps. So I could do I could really do the 18 amp range, and that's about it, because I could calibrate that at 10 amps. Even the 60 amp range is getting a little light, and the 180 amp range at 10 amps way too far down the meter scale for it to be functioning. If I'm going to do an alignment, even if I'm going to fudge the alignment a little bit, I want it to be at 75% or better of full scale. All in all, we can put this into service, knowing all of those limitations, and we can start working on getting the gear we need to calibrate this thing. Obviously, my 7510, which does have a 10 amp range, only has a 10 amp range, and well, if it's only got a 10 amp range, it's not going to do me much good for these two buttons. So stuck at 10 amps. So that's where we're at for right now. Thanks for swinging by the lab, taking a look at this Transistor Devices Dynaload. If you would like some additional content, Patreons are running about 5 videos ahead right now, so head on over to them, or head on over there and join the discussion and the patrons over there. Their support to the channel helps immensely, helps videos keep coming out to YouTube, helps me keep the lights on, and their support helps way more than anybody knows. If you're liking the content and would like to hang around to see some more, hit all the YouTube buttons, like, subscribe, and bell, and hang around. As always, more is always on the way, and I will see everybody in the next video.